Good afternoon, kiddos. Today we're going to talk about the instantaneous rate of change, which is better known as the slope of the tangent line. So what is a tangent line? A tangent line is a line that touches your graph at exactly one spot. So you talked about secant lines and tangent lines back in geometry. So the secant line would cross the circle twice. The tangent line would touch the circle exactly one time. It's the same thing here, except we're no longer doing it on just a circle and limiting ourselves to that. We are basically looking at any function on the xy coordinate plane. So if we want to sketch a secant line through a f of a and b f of a, we can take and we can essentially just draw a line that connects a to b. So then if I want to start drawing tangent lines, what I'm going to do is I'm going to start drawing lines parallel to this on this graph. And what happens is as I continue to draw these parallel lines, the distance between the 2 points is getting shorter and shorter and shorter until I get really close here, and all of a sudden that distance goes to 0. And when that distance goes to 0, that is the tangent line. So if I look at the second graph and I take the same approach, I can connect my 2 points, a f of a and b f of b, and I can actually go 2 different ways. I could go this way drawing the parallel lines, and the distance between the 2 points is getting smaller and smaller and smaller, and I end up with a tangent line right here. I end up and I can connect and draw parallel lines until I get right here, and now I have a tangent line. And I've had some students in the past like maybe say that I have another tangent line right here. It's debatable, it's really close, it just depends on how you interpret that graph being drawn. So basically that is what's happening. So when we think about what happens, and I'm using the phrase the limit as h approaches 0, of the function, what's happening is as h approaches 0, it's just these secant lines, parallel secant lines, getting shorter and shorter and shorter until I run out of room and the distance is 0. All right, how do you find the slope of a line if you only have 1 point? Well, technically you don't. Okay, so technically you don't, because you only have 1 point and we cannot find slope with 1 point. So what we're going to do is we're going to use an alternative method. So we are going to take and use the first derivative, which says if y equals f of x, then the derivative of the function f with respect to x is f, and this notation right here is stated as prime. So f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. So we've actually practiced this difference quotient earlier. What we're going to be adding to it is this limit part right here. And this is the first derivative, but we're going to use algebra to find the first derivative and not calculus. All right, so if I have f prime of x, there's just a few things you should know. So note 1. We did this when we did the difference quotient, so some of you may not need to write this all down, but we are going to substitute f of x plus h into the equation. So remember, I talked about this being 3 steps. So we're going to do 1, substitute in f of x plus h. Step 2, subtract the original function, and when you subtract that original function, please make sure you put everything into parentheses so that the sign gets distributed correctly. And then you're going to divide by h. So I always think of these as kind of a 3-part problem. And then the biggest thing I see students do is when we do the first derivative, you cannot lose this limit part. If you lose that limit part, then technically I will count off points, because until you apply the limit, you cannot make that statement go away. All right, note 2, you are going to evaluate this function once you get all the substitutions made. You're going to GCF out the h, and the h in the numerator and the h in the denominator should cancel out. Again, when we did the difference quotient in the beginning of the chapter, we talked about that. If your h's do not cancel out, then you have made a mistake. And then note 3, substitute in the 0 for h and evaluate the limit. And hopefully whatever you did to simplify, you will no longer have division by 0 and the limit will exist. All right, so we are going to find the slope of the tangent line of the function f of x equals x squared minus 3x minus 10 at x equals 4. And then we're going to write our answer in sentence form and interpret the meaning. All right, so I'm going to find the first derivative. So notation is important. I'm going to substitute in the 4 at the end of the equation this time. The next example, I'll substitute it in earlier. So make sure you put the prime. And this is going to be the limit as h approaches 0 of f of x plus h minus f of x all over h. So if I continue this on down, you're going to have, as h approaches 0, I'm going to substitute in x plus h everywhere I see an x. And then we're going to subtract the original function and put it all over h. I kind of suggest you hit pause, do the work on your own, and then come back and rejoin me. So here I go, hit pause. Welcome back if you've already finished. And if you're doing this correctly, you really kind of see patterns, like you know what should be happening. This is all over h. So now when I start canceling, I have a positive x squared, I have a negative x squared. I have a negative 3x, I have a positive 3x, I have a negative 10, and a positive 10. So just remember, everything in this last term right here should cancel. If it doesn't, and you're dealing with a polynomial, you know you have done something wrong. So if I continue on, the limit as h approaches 0, you have 2xh plus h squared minus 3h all over h. I can GCF out the h. So you have h, and you have 2x plus h minus 3. H's cancel, and now you can substitute in 0 for x. So you have 2x plus 0 minus 3, which is going to be 2x minus 3. So if we want to interpret the meaning of our answer was f prime of x equals 2x minus 3. So what that means is the slope of the tangent line at any point x, oops, that's an x, it's really bad x, is 2x minus 3. All right, so if we want to find f prime of 4, that means we're going to take 4 and we're going to substitute in the first derivative. And yes, you putting this little prime notation right here is super important. So we're going to take 2 times 4 minus 3. So 8 minus 3 is 5. So what that means is the slope of the tangent line at x equals 4 is 5. So at this point, I really would like for you to get your graphing calculator, and we are going to graph this. We probably need to write the equation first. So we want to graph the original function, and we're going to graph the equation of the tangent line. So the original function was f of x equals x squared minus 3x minus 10. The first derivative was 2x minus 3. So if we take and we put those, the first derivative was 2x minus 3, and the slope of the tangent line at 4 was 5. So if we take and graph the original function, so we're going to put the original function, and I'm going to write the equation of the tangent line at 4. So I'm going to come in and I'm going to substitute in f of 4 into my original function. And remember, when you substitute a point into your original function, you are just finding a point on the graph. So 16 minus 12 is 4, so this is negative 6. So what happens here is I have some point for negative 6. And if I want to write the equation, I can do y equals 5 times x minus 4 minus 6. So I want you to take a minute and I want you to put both of these equations into your calculator. All right, so if you put both of those into your graphing calculator, you get a graph. You have a parabola that actually intersects the x-axis at -2 and over here at 5. So you have a function that looks something like this. And so if we look at the slope of the tangent line right here, if you graph the other line, it graphed right here. So that's the tangent line when x equals 4. And if you went and you looked at the table of values, so if you go second table on your calculator and you look at the x value, so when x is 4, you actually have a value for your first equation, which is -6, and a value for your second equation, which is -6, which tells you that the graphs actually touch at the point for -6. So that is kind of tying up one example. So let's look at a couple other examples. Okay, I'll be honest with you, this is kind of a long problem. You might just want to get your composition notebook out and do the work for this in your composition notebook. I can tell you that if you write big at all, you do not have enough room to do this right on one slide. I don't even know if I can fit it all on one. All right, so method 2, we're going to substitute x into the difference quotient at the beginning of the problem. This is not really the way I suggest, mainly because you have to do it over and over and over for every number, whereas what we did in example 1, we used x equals 4, but you could very easily do x equals 5, x equals 6, x equals -10, and you could plug them into the first derivative at the end. When you substitute at the beginning, then it's only the answer for that one specific equation. Anyway, here we go. So what we're going to do is we're going to take the first derivative. So f prime of x equals the limit as h approaches 0, and do not drop that during the problem, of f of x plus h minus f of x all over h. In this particular problem, we have h equal, or x equals 1, so, or -1, so we're going to find f prime and -1. And it is the limit as h approaches 0. And we're going to substitute in -1 plus h minus f of -1 all over h. So when we do this, now we're going to take and substitute in -1 plus h everywhere I have an x in my original problem. So to take out the x, substitute in -1 plus h. That plus 6 is underneath the radical, minus f of -1, so I'm substituting in a -1 all over h. Oh, I did it. I dropped the limit. God dang it. All right, so now I'm going to put the limit bigger in this problem. All right, so now I'm going to do some math. So I got the square root of -2 plus 2h plus 6 minus the square root of 4 all over h. And if I keep on plugging through the math, then I have the square root of 4 plus 2h minus 2 all over h. And now I've hit the great debacle because I cannot cancel out my h's like I normally would, because one of them is underneath the square root and one of them is not. And when I substitute in h, I still have division by 0. So lo and behold, we have to think back to those three methods: factoring, rationalizing the numerator or denominator, and simplifying the fractions. And we have to figure out something. So this is one of those problems where you're going to have to rationalize the numerator. So I'm going to take the square root of 4 plus 2h plus 2, and I am going to multiply that over itself. And I'm going to come up here to finish this problem. So when I do that, f prime of -1 equals the limit. And what I end up with is 4 plus 2h minus 4 all over h times the square root of 4 plus 2h plus 2. So that is what we did in a previous lesson. So now when we look, the 4 and the 4 cancel out. This h and this h now cancel out. So f prime of -1 equals, that's horrible writing, the limit as h approaches 0. And I see that I forgot the h approaches 0 on that part. And in my numerator now, I'm simply left with 2. And in my denominator, I have 4 plus 2h plus 2. And so now I am able to plug in 0. So f prime of -1 equals 2. And I get the square root of 4 plus 0 plus 2. So f prime of -1 equals 2 over, the square root of 4 is 2, plus 2, which is 2/4, which actually simplifies down to 1/2. All right, so the slope of the tangent line at -1 is 1/2. So what this is saying is the slope of the tangent line at -1 is 1/2. All right, long problem, lots of work, lots of places for mistakes, and that's just kind of how the rest of this chapter rolls. So do your math neat. Do not try to cram it into a very small space like I did. Use your composition book to show your work for your homeworks. And I don't need that slide. All right, so let's talk about instantaneous velocity. So what is instantaneous velocity? It is the velocity at a specific point on the graph. So it's not looking for what's happening over the course of time. It's what's happening at one specific instant on the graph. And it is basically going to be the slope of the tangent line. So we're going to find it exactly how we just did it. But instead of f of x, it's probably going to be d of t, because it's distance as a function of time, which means our first derivative will actually be d prime. So it will be d prime of t. So we are changing letters, but it doesn't really change how we do the problem. All right, and like again, to find the first derivative, except instead of using f of x, we're going to be using d of t. So example 3, probably do this one in my composition book if I write big, because you're probably going to run out of room. The distance, and I did not put on the current notes in feet, so you might just add in feet, of an object above the ground t seconds after it is dropped is given by d of t. Find the instantaneous velocity of the object at the given value of t. And then they give you the equation. So d of t equals 25t minus 16t squared when t is 4.1. So we are going to start off by finding d. Oh, I don't like that color. Let me switch colors. So we are going to find d prime of t, which is going to be the limit as h approaches 0 of t plus h. Oh, I forgot the d. Let me redo that. Limit of d of t plus h minus d of t all over h. So this is going to be the limit as h approaches 0. And now I'm going to substitute in t plus h. So I'm going to do 25 times t plus h minus 16 t plus h squared minus my original function, 25t minus 16t squared all over h. All right, so some of you are better off just to hit pause and to do the math on your own. Some of you like to follow along with me. However you want to do it, I don't really care. So 25t, just to distribute the 25, plus 25h minus, remember this is going to be t squared plus 2th plus h squared. So if I distribute the 16, it's negative 16t squared minus 32th minus 16h squared minus 25t plus 16t squared all over h. All right, I was afraid of running out of, so I'm going to go to the next slide. This is basically exactly where I left off, so if you need to double check this, then you can. Oh, except I feel like I see a loose h here. Yes, I don't think I should have this plus h. Ignore that. Okay, so I'm going to start canceling things. So there's negative 25t and positive 25t. There's positive 16t squared. There's negative 16t squared. And then everything else has an h in it. So this is going to be d prime of t equals the limit as h approaches 0. And you have 25h minus 32th minus 16h squared all over h. This is probably faster for you to do on your own instead of listening to me. So those of you who actually need to GCF it, some of you can do this in one step without showing the GCF, and that's fine. Oops, 32t minus 16h. So at this juncture in life, the h's cancel, and we have d prime of t equals the limit as h approaches 0, and this is going to be 25 minus 32t minus 16h. If I put 0 in for h, I am left with d prime of t equals 25 minus 32t. All right, so this is the instantaneous velocity at any point t. Okay, so now basically what I'm going to do is, I'm interpreting the answer, I just did that. So that's the instantaneous velocity at any point t. If I want to find the instantaneous velocity at 4.1 seconds, just remember that d prime of t is the instantaneous velocity. So we're going to find d prime of 4.1, which means we're going to substitute in 4.1 into the equation. And remember, that was seconds. And so if you substitute into the calculator, you get negative 106.2 and that is going to be feet, is going to be my unit. So the slope of the tangent line at 4.1 seconds into the path is negative 106.2, and because that's the slope, that tells you that the object is falling. If the slope of the tangent line was positive, the object is going to be going up in the air. So if you graph that, and you looked at what's happening when time was 4.1, the object would be falling. All right. Now, if you want to know how high the object is at 4.1, that means you would go d of t, and you would find the distance at 4.1, and so you'd plug 4.1 into the original equation. So 25 times 4.1 minus 16 times 4.1 squared. And I have not put that into my calculator, but I can do that real fast. So 25 times 4.1 minus 16 times 4.1 squared. So the object, is actually 166 is moving at 166.46, and I think that's feet per second. So anyway, so you get d of t. I think this object somehow is underground. This doesn't really make sense to me. I will research it and we will talk about it. We will talk about it in class when we get to class, whenever I see you next. So, okay, so just remember, d of t is totally different than d prime of t. So those two are not the same thing. And at this point, I am going to stop You have homework to do, and if you have questions, we will address those when we get back to class. Have a great day. Bye-bye.